Hello, this is lesson 26B. We are going to continue to solve rational equations, and I'm going to try to talk really fast because we have a lot to cover, and it's not just solving that we're going to cover today. It's also going to be how to write and justify our answers. So keep up with your notes, use the pause button, and go back and re-listen to a lot of this information. So the vocabulary here is very similar to the vocabulary we've been dealing with. There's a couple of things that you may hear me say. You may hear me say reveal, which means to show up. And you may hear me say expand, which is different than factor. And you're going to hear me say solve, which is another way for me to say isolate x. So just a heads up, those words are coming at you. The first thing we're going to do is take a look at number 1. We have a rational expression and an equation. So we're going to solve this. So when the directions say solve, what they're really asking for you to do is find x. Find x. So in order to find x, we are not going to cross multiply. Do you hear me? We are not going to cross multiply. Instead, we are going to find a common denominator. So, but what we are going to do is find a common denominator, and I'm going to continue to abbreviate common denominator as CD because it's long for me to write. Now, when you approach a problem, if you see a fraction, the first thing you got to do is you have to call out the values of x that would make this function undefined. So, in this function, it is undefined when the denominator is equal to 0. That means if we plug in a -3 when x is equal to -3 and when x is equal to -6. If we plugged in a -3, this would become undefined. That's not good. If we plugged in -6, this would become undefined. That's also not good. So that's the first thing we're going to do. It's actually going to help us because afterwards we are going to, once we solve, if any of our answers become -3 or -6, then we know they're extraneous. Okay, so finding a common denominator, here is a trick. It's not a trick, it just makes sense. I have 1 over 2, let's do x over 2 is equal to x over 3. And if I needed to solve this and find a common denominator, you would say, oh, your common denominator is 6. And I say, 6, you mean 2 times 3? And you would say, yes. So to find the common denominator, all you had to do is multiply the two denominators together. So in this case, our common denominator is going to be x plus 3, and it's going to be x plus 6. All I did was, just like this 2 times 3 is 6 over here, I'm going to multiply x plus 3 times x plus 6. That's my common denominator. That makes it really convenient because if I rewrite my problem, x over x plus 3, I can multiply this by x plus 6, x plus 6, and 8 over x plus 6. And I'm going to multiply by x plus 3 and x plus 3. Okay, so at this point, we are going to multiply both sides, and then they're going to have a common denominator. So I'm going to have x times x plus 6 over x plus 6, x plus 3 is equal to 8 over 8 times x plus 3 over x plus 6 and x plus 3. Okay, we also learned from class that a over b equals c over b when, of course, b cannot equal to 0. However, if your denominators are the same, essentially that means your numerators must also be the same. That is why this numerator and this numerator are going to equal each other in this next step. So now I have x plus 6 is equal to 8 and x plus 3. From here, you have to solve for x, and by solve, you're going to expand. Expand means to multiply. If you need to write that down in your notes, write that down in your notes. Expanding, you're going to multiply, and then you're going to solve. So I'm going to multiply this out, x squared plus 6x is equal to 8x plus 24. At this point, go ahead and isolate x. And now you're like, wait, I have an x squared here, I have one x here. If only there was a way that we could solve for x when it looks like a quadratic. Oh wait, we know exactly how to do that. X squared minus 2x minus 24 equals 0. I want you to guess, why are we solving by setting everything equal to 0? We're going to use zero product property. But we can't just solve for x in this case, we have to factor first. So I'm going to think of factors of negative 24 that add up to negative 2. And I have x is equal to negative 6 and x is equal to positive 4. This is what we've been training for. This is why, one of the reasons why we've been practicing factoring and solving for x of quadratics, because now we can use this skill to solve rational equations. Pretty cool. So at this point, you should know to write out two equations. And you're going to get x is equal to 6 and x is equal to negative 4. Check! Oh my goodness. You may have to put like a caution sign here. Check. Are your solutions going to make your equation undefined? So scroll back up, and we said it's going to be undefined. This is a U and D. Undefined when x is equal to negative 3 and negative 6. Oh no, what was our answer? Positive 6. Okay, so these answers check out. So therefore, the solutions to the equation are x is equal to negative 6 and x is equal to negative 4. Okay, so your math proves this, but this is just what it says in words as well. You have two more examples to do. It looks like this and this, but they are going to be in other videos. So watch part 2 and 3. Bye for now.